My name is Markus Eisele. Thanks for joining me today. I work for Red Hat as a developer advocate, which is somebody who's really looking into some cool technologies and has some time to share his knowledge with all of you here. So if you want to stay updated with what I'm looking at right now, just follow me on Twitter, it's myfear, or reach out to me directly. So markus@jboss.org. I don't mind taking emails, and I'll answer them. This is one of my favorite talks because of many reasons. Before I joined Red Hat, I had a life as a consultant for many, many years, like 14, I guess. So I've been on-site with customers, creating large-scale Java EE applications and platforms and infrastructures all around them. And the thing that bugged me the most has been most brilliantly captured by one of my favorite quotes so far. So I think that we've always seen some very popular things, and we've always tried to incorporate them into what we do in our daily lives as building applications, designing software, building platforms and infrastructures. But for sure, not all of them is done right, not all of them is really cool. So we all learned our lessons over the past couple of years. And if you look back at how you actually designed applications, like back in the days, this is what it looked like. And this is what many customers are still using. So we have application server clusters, and we have a bunch of applications on them. Totally perfectly packaged as EAR files, as WAR files. We have that centralized DB. We have a hell lot of infrastructure around it, like just think about security, enterprise access management. We have some more stuff, like cross-cutting concerns, like centralized logging. That's basically been the boundaries that we try to operate in. And we did our best to modularize and to build some recent designs into our software. Reusability, was that the main driver back in the days? Not exactly. What we tried to make application development scale. So we want to have the ability to actually develop a large project with, let's say, 200 developers. This is just a totally different story than just sitting there and building your own application. But that's what we've been doing. So what did we came across while doing that? We had a bunch of technical implications, right? So this is what we typically look at as a monolithic application these days. Like it or not, it's been packaged, it's been a single artifact. So yeah, we've been sharing some jars, not that much. What I liked the most was the big, we push everything to production, right in schedule, on time, 24th of December. This is exactly what we did, most of the time. We failed gracefully, but no matter, it was planned, it had to be there, right? And I hated the most, the single database scheme. So just imagine 200 developers working on a project, and some people start to change the database and start to change relations. That's not really going to flow. Well, we did it. Projects have been really, really large, like large code bases. And this is just a teensy example. I've seen projects growing over 4 or 5 million lines of code. And that was just Java. So not talking about the 8 millions in PL/SQL on the host systems buried somewhere. So heavyweight infrastructure, like we've not been using lightweight Tomcat. We've been typically using something like Big Blues, Big Reds, complete package, like not only the application servers, but also stuff around them, like the development tooling. That was fun. And one single bit out of my past, so I've not been a systems architect, but over the years you kind of grow to be the dinosaur in the company when it comes to Java EE applications. And if something was about to fail, my phone started to ring. And I had to come on and try to make that work again. And one of the first things I looked at was test cases. And there's been so many of them. I mean, most of the projects actually ran 5 to 10 years back in the days. That's been the production life cycle. And none of them has been updated at all. It's just been that ground base of test cases. Barely new features are covered by any test cases at all. There's been a lot of pressure trying to make something work, right? But that's been a brief overlook about the most important technical implications that we're pretty much still facing right here. We also had some team implications. So 20 people, that's more the smaller teams that I ran. We had a multi-month test cycle to get everything really up and running. So the interactions between the different parts that developers were working on really had to be tested. And that was barely automated. That changed a bit over the time, like looking at stuff like DevOps. But still, large corporations, large ISVs, they have a hard time adopting those agile methodologies, and they try to make it something more like process-driven still as of today. So ending up with that, we had a huge database of bugs. It's like millions of bugs. And this was totally because we never defined any user acceptance tests back in the days. So really hard criteria is where to measure if something is a bug or not. Another thing is we had a very technical design approach back in the days. So I think nobody really tried to build something like services. What we did, we cut layers into technical responsibilities for our applications. That wasn't a failure back in the days, but we know better as of today. As a matter of fact, we barely have any kind of business objects in those old applications, which I still consider kind of enterprisey, just because they run so long. Multiple teams, this is mostly a thing that really starts to bug project management without big projects, but it still required a lot of oversight and a lot of coordination between the teams, even from a technical perspective. So I've seen fancy constructs back in the days, like we had multiple architects on the whole project, one was responsible for the database, the other one for the UI stuff, so that's been a hell lot of coordination. And still, if we solve all that, if we make it work, what we obviously did back in the days, the requirements for those applications change. Like, especially if you look into some particular industries, let's say the insurance industry, which is highly driven by law requirements. So whenever something new comes up, then you really have to change even the oldest applications, though there's never going to be an end. And as a matter of fact, because of the technical design approach, those new features tend to be really huge because you have to touch every single layer and you haven't had a good domain encapsulation in it. So cross-cutting concerns, just speaking of them, is another big thing that barely could be implemented back in the days, just by putting some external systems in front of it and trying to let them take care for it, right? How could that happen? I mean, I call myself a decent architect back in the days. I've been up to date with all latest developments and design decisions. There are a lot of potential reasons out there. Some of my team members told me, actually, we don't have a real technology stack. So we are stuck with any platform decisions customers make, right? So there's no single chance for us to really drive technical innovations in enterprise projects. And honestly, this application has been grown. I mean, they estimated it to be a 5-people project. And at the end of the day, we had to throw in 200 to make it work in time. And seriously, I mean, we don't have any time to educate ourselves. So you're all very lucky to be here because you're taking care of your education. Fine, great. Let's not forget outdated infrastructure. There's nothing that can help us solve all those stuff. And we're a little bit lazy, we're developers, right? So this happened. Where did we go from there? What did we do to prevent that? We accepted that some things will never change in time, and that's better to not touch systems anymore after a decent amount of time they've been grown, right? So instead of just looking at host systems as legacy, we started to look at basically every system as a legacy system, and we started to think about application integration. So some fancy minds introduced something like the enterprise service bus. So instead of just having one big monolithic application, we had a bunch of them talk to each other. Funny, web service, all the things, right? So that's been the message back in the days. We want standards. That's exactly it. That helps us a lot in that whole thing. We have a little bit of integration requirements, right? So we can make them talk to each other. And this is really enterprise. That's what kept all the companies telling us, right? So this is what you need. It's an enterprise service bus. That sold so well. It's centralized. So I don't actually have to look over all those teensy little departmental installations anymore. I can put it in operations. Centralized. I can define standards on how those things are run. Yeah, we had some license issues, like it's been huge. ESB infrastructures are just not cheap. What else do we have? I mean, at the end of the day, this is all lies, right? So it's not made anything better. We had to look into every single application over and over and put some web services in that were never intended to be there. And we ended up with a bunch of logic in the ESB. So instead of evolving the individual applications and making them more independent, we created a new centralized piece which contained all of it. Not helpful. Technical implications in that approach. The code base doesn't shrink at all. So, plus, developers now have that fancy, totally bloated and overloaded IDEs, right? So we had a kind of program make that shitty ESB thing work. Not good. The whole application wasn't understandable at all anymore. There's been a few people being able to overlook that up to a certain scale, but still, I've seen a lot of gremiums being built to just decide on which application to connect to what, because it's just been insanely hard. And another thing that's been really hard is testing, because literally nobody was able to test it in conjunction, like a complete integration test, on your own laptop anymore. This was stupid. The dependencies, insane. Don't even want to think about it anymore. And as a matter of fact, even the smallest change at the right position had really insane implications on the complete application. So it's been not only difficult to scale, but it's also been very hard to change at the end of the day because it's been, to a certain kind, already highly distributed. So we had to learn a bunch of lessons to get that rewired at the right positions to make it work, to change it, to improve it. But that's exactly what we did. So instead of rolling out new application versions, we just rewired some stuff. We just entered some new fancy routes in whatever ESB product and made it work. Plus, just a little teensy story here. A customer object isn't exactly the same in the whole process of whatever companies are running. Like in the very early days, it's a prospect. So we want to mail him, we want to have a phone number, and that changes. Let's just look at a simple sales cycle, right? So this object is going to be enhanced, and not having a corporate data model, which is the prerequisite for a really successful thing, leads to a lot of transformations in the ESB and a lot of talking to each other. So data segmentation was the thing where we learned the most over the next years. Scaling, yeah, let's not talk about scaling. Okay, that obviously didn't work either. So again, where are we today? Who knows that picture? Scream. It's actually Netflix-like. This is the only picture I can find still, as of today, of the Netflix architecture. And I think we can think about it whatever we like. It's, as a matter of fact, even as of today, even if we all acknowledge that it's not the only way to architect projects, we are going to evolve parts of our applications into microservices. And this is not a bad thing to do. The idea behind all of that isn't new. It's never been new. So that's what we've all been trying to do, like starting with components, now going on to services, right? And the biggest challenge here, obviously, for architectures is how to find the right service granularity, how to identify the services. And if you expect the answer in one slide, I have it. It's a bunch of keywords. Consider that your homework, because I'm not going to talk about any methodologies, how to find your data objects, your services. I think this is a good list of topics for you to look into and educate yourself a little bit further on that design approach. What I really like you to look into is what we basically did since a while. So try to find the right use cases. Try to model the right nouns and really follow that single responsibility principle when looking at services. But what I really want to talk about today is something else, because I might like microservices. I might like the architectural approach here. What I really love still is Java EE. And is Java EE ready for microservices? What do you think? There are some people running around telling us that Java EE is the exact right platform for microservices. And let's try. This is what it looked like before. I stripped the first graphics down a bit, right? So we had our deployments, we had the database, a load balancer in front. What does it take to actually make that microservices-ish, turn it a little bit into microservices? Let's assume that a service is packaged in some way, and let's assume that we're still trying to make it work with Java EE, so we'll pretty much end up with WAR files. So that's what EE7 is pretty good at, very lightweight, very easy deployable, right? So we need to find a service, and then we need some glue code to glue these extracted services into our old application, right? And I'm not even talking about protocols at that point, but just thinking about it as taking one of the modules out of your existing application, putting some glue into your old application, and extracting it into a new WAR file. That's pretty much it. This is what Java EE has to deliver in terms of specifications. And looking at most of it, I have to say it's not really helpful if I want to do something like the microservices approach. What could we need here? We might need a component model, right? It's going to be a service. It will have components. So we might use EJBs. We have persistence. We want to access the database in some way, so we might use JPA. We need some communication, serialization, so let's assume microservices is still something that most people try to make happen with REST-based services. So we'll have JAX-RS, JSON-P. That's pretty much it, right? So I mean, a little bit of dependency injection could be worse. So yeah, we use it. We might have some other things that we want to use, but as a matter of fact, we don't need the full-blown platform, and there's no microservices JSR in here, not now. So this can be as simple as a microservice can look like, Java EE, and this is pretty much what I think it will be, like a stateless EJB which has a JAX-RS endpoint. And that makes sense to me. If you really are forced to use Java EE, and I'm using that word intentionally because I don't think it's the perfect platform, but I totally acknowledge that there are many companies out there who made that platform decision way back and who are not adopting latest technologies like in nothing. So you'll have to find a way to work towards merging new ideas with existing applications, right? So, and this is the approach. Looking at that, this is all we need. A bunch of specifications, and I highly recommend that you really look into the application server profile that you're using. Web profile is pretty great. It encapsulates most of what you will need at that point. Is that all? What do you think? We're done in 20 minutes talk? Might not be it, right? So I actually have to hurry up a bit. Lightweight runtime. Java EE servers can be lightweight. Like, look at Wildfly. Blazing fast, lightweight, easy startup time, so nothing to worry about. Let's think about security. Service security, cross-service security. This is something that's not really defined by Java EE. I mean, it's still struggling with the application internal security to make it easy and programmable. At that point, we have nothing out of the box from the Java EE platform that helps us here. Transaction management is pretty great. This is one of the key benefits of Java EE, but also it doesn't cover cross-service transactions, and we're not talking about JUGs even here. Scaling? Nothing particular. We can scale, but it's more like an infrastructure thing to do. Same with load balancing. Deployment isn't exactly getting easier. It's still the same pretty much. So I expect it to be a little bit smoother. So we're missing configuration, like on the whole thing. There's nothing like services as an object, as a container object that we could use in Java EE. So we basically need to take care for everything around all those requirements that we like to raise against services, right? So versioning, monitoring. Yeah, we can monitor application servers. And some of them actually have some more intelligent ways of monitoring some runtime objects. But that's pretty much not it for services, right? So I'm not talking about governance at that point because there's nothing there. And beside of that, what else does EE microservice use and need? This is what you find in most of the organizations out there. They're still trying to virtualize infrastructure. So do we really want to do that? Like spin up a complete application server instance for a single service, which is kind of the model that we want it to be? No, we won't. Seriously not. So this can't be the route. We need something really, really lightweight for that approach. I think Docker will help here. It's more or less a pointer for you to keep in mind that I don't have a solution at that point. I think this is where Docker fits into all the developer infrastructures at the very moment. It's more network, it's more infrastructure, but we still will have to handle it as developers. Not only tomorrow, it's like, it's good to know what it is as of today. So it's a really lightweight stack that you could run your application server on. And if you can find a really lightweight application server at that point, that might be the perfect immutable instance to run a service on, right? But even if we put all of that together, even if we assume that Docker will help, that some other things might help, there's still a hell lot of open and red points on that list. And I'm not really saying that this list is anything but complete. It's just giving you a bunch of pointers to look into. So scaling might be a Docker thing. So there's Compose, we can use Kubernetes. So there's a lot of thoughts going on around that. The pre-configured images make everything a little bit more lightweight, especially when they're already downloaded. So we just have to start the containers, which is just easy in Docker. So this is kind of the solutions. Another thing is synchronous versus asynchronous communication. That is something that Java EE supports. At that point, you just need to make the right decisions when to use what for services. Just a side note from me, I personally believe JAX RS isn't it. So not for enterprise-y contexts. You need a lot more than JAX RS can provide, especially at that point when it comes to transactions. So I really like to see people start to use messaging services, messaging protocols for microservices, something like MQ. But you know what? The good thing is, even today, we don't have to solve everything at once. So this is still very evolutionary. We don't have to have something which is ready and covers everything in depth and detail. So I took some time to put the pieces together that we really need for Java EE microservice to make it work and fit most of our requirements. We obviously have a client. We still will have a load balancer. I think we need some infrastructures in front of them. So we need to find a solution for service versioning. So some kind of API gateways management solution that will take care of that. Further on, we need some cross-cutting fancy security shit there, just to make the cross-service security work. I mean, we're not even talking about services running in the same container. We are definitely talking about services running on different instances across your infrastructure. We need a cache. I highly believe if we started chain services, looking into that a little bit later, like the potential service patterns, this is all going to burn down to performance. And if you really want to make that fly, you need to plan with the cache at that point. We have a DB, I'm pretty sure. This is what I think could be a feasible solution for Java EE-based infrastructures as of today. It just throws out a bunch of open source projects, which you can totally look up and use as of today. So just go out, download, educate yourself a little bit about it. It's all going to be homebrewed at that point, but we're getting there, I think in a couple of months. So let's just briefly walk through. Undertow actually is the new web server in Wildfly. The good thing is it can be used as a load balancer. So the same infrastructure component like Wildfly that you use for your application can also act as a load balancer in your infrastructure. That makes configuration here in terms of different Docker images very handy, very easy, and doesn't introduce a new component that you have to handle. API Man is an open source project who actually manages the complete governance around services. So you could define access levels, you can define versions, and you can manage versions. It's pretty straightforward. It's very young, very fresh, so still growing, but totally a thing where you should keep an eye on. As much as Java EE doesn't catch up with that requirements towards microservices. Who's using Wildfly here as an application server? Well, what's the rest using? Like, hands for Tomcat, please? A little bit. Hands for Big Blue? Oh, poor you. Hands for Big Red? Okay, fair. That's good. Cool. Like it. I'm not talking about Wildfly. You know what it is, so just go there, wildfly.org. I totally can recommend it. It's easy to use. And this is actually a very nice screenshot from JBoss Fuse, which basically is a complete wrap-up of a bunch of different open source projects. But this is what I wanted to show you here is like the UI that also has the Fabric 8 underneath. So the whole management of the complete infrastructure, the open source version of it is Fabric 8. That's where you have to look into. And Fabric 8 is, at the very moment, completely revamped from whatever it's been before into a Docker and Kubernetes-based management infrastructure. So it basically orchestrates, manages your complete middleware requirements. You can capture all your middleware software in Docker containers and Docker images, and Fabric 8 will give you a very perfect UI and also delivers features around service discovery. It obviously will support OpenShift, but it's particularly meant to take care of your middleware infrastructure, and that's not only application servers, that's every instance that you might need. As of today, it's still in community, so you'll need to wait a little bit more or start playing around with it on your own. Microservices pattern, does it make sense? An architecture talk without pattern wouldn't be one, right? So let's give it a try. The pattern basically evolved in Red Hat in terms of discussions between a bunch of people trying to find a way to make that usable for all of you. So this is kind of the first iteration that we are thinking about, and I'm not saying in any way that might be final. I'm taking all complaints or ideas from you, just send them my way, right? So the first thing is actually what we call the aggregator pattern. That is pretty much a client using services. So this is what we have with mobile phones as of today. I mean, the mobile phone knows a bunch of back-end services it connects to. That's pretty much it. So if we have anything in terms of service logic, when to call which one, it's all going to be handled in the client. I think we've seen that kind of architecture before, like with JavaScript, single-page applications or whatever, so that's not really new. The new part here is pretty much the granularity of the services that we're proposing for that whole thing. 3 different service calls end up on 3 different services, right? Much more likely, we'll see something like that. So you'll have a chained service pattern. And this seriously, still as of today, scares the shit out of me because I'm not really sure that this will fly out of the box. If you're not careful, if you're not monitoring your whole infrastructure and know about the runtimes of your services, this might totally hit you. So basically one service can call another, It's called fan out. And I like that picture. It's very, very flowerish for me, so it works. The response is actually collected into a single response by the first called service at that point, and that definitely will lead to longer run times at that point. What else do we have? We have a branch pattern. Sure, if one service needs to call 2 other services, this is even getting worse at that point. You see each service has its own database attached, and I'm not getting tired to emphasize that I still believe in caching at that point. This is mostly because I'm afraid of the performance issues that you might run into. But we've seen some experiments at that point, so pointing exactly in that direction. This is a dependency graph, right? So looking at your architecture for future versions, you definitely need to find new ways to document your architecture at that point, because otherwise it's going to totally blow up at some point. I think there are a lot of lessons that we learned out of the ESB phase, which could be applied here, just on a different granularity. One pattern which I think isn't exactly what microservices propose, but will be still relevant in enterprise situations, is actually a shared resource. So at some point, you won't be able to separate your databases anymore and exactly assign one responsibility to one service. So we definitely need to plan for something like shared databases with some common information in it. Looking at all my experiences from the past, even if we try to make that happen with just normal Java EE applications, it's still very hard. And at some point, all the data models divert again. So this might be the most important part to look into to keep the data model sane and separate. Asynchronous messaging is totally what I like to see in enterprise situations when it comes to microservices. I am a strong believer that REST services won't carry us anywhere, to no extent and no scale. So looking into something like ActiveMQ is a good solution here. And I still believe that it solves a lot of other issues around communication. And I think it doesn't look bad from a service perspective. It's just using different protocols. I'm a little bit worried. If you really use some central component like a broker at that point, you start to introduce something centralized again into a decentralized world, which isn't exactly what we want at that point. But it might be the only way to do it, or the technology is evolving also into new architecture patterns. Is that easy? Are we going to do that? Who's convinced that he's actually going to take on microservice soonish in his or her applications? 0, 2? Seriously, 3? Okay, that's not much. I hope so, seriously. I don't want to see that used across the board. And I think we've seen some recent posts by luminaries about that topic. It's not the one thing that solves all our needs. But I still believe that there are decent use cases out there and that we don't all have to be like Netflix. So the good message is sit back, relax a bit. We're in a pretty good space here. And whenever we come across a requirement that may look like it might be solvable with microservices, we have a way of doing it. But still, please keep in mind, there is a hell lot of challenges around all of that. No silver bullet. The dependency graph itself for a decent-sized microservices-based application, I mean, the Netflix picture perfectly captures it to me. If I would leave my company at some point and I have to hand over a complete project in that shape to a new architect, and I have to explain what all those services do, I better not. I better be out the door before that. So what else do we have? I think looking back at what we learned with large-scale enterprise projects, team communication might be a big issue. So assuming that teams are responsible for services, but how many people actually? I mean, just from a project planning perspective. Assume we have 2 people implementing one service. One is on vacation all the day, and I mean, somebody gets sick, so we have to have at least 2 people on a project, right? On a service. Just scale that a little bit. Where's the point where teams get larger and are responsible for more than one service in implementation? I'm not sure yet. I'm sure of one thing. Communication will be another big issue if we start scaling microservice into the enterprise. And one of my personal favorites, whenever my phone rang back in the days, and I had to look into architectures that's been designed, I've always seen people fallen in love with the architecture. So over-architecting things might be something that we got rid of over the last couple of years because we've all been a lot more pragmatic and we've all been a lot more focused. I think there's a good chance that we start doing that failure again with that new microservices approach. So this is on my watch list of things, not talking about performance. But that's not it. There's another big list of things that I'd like you to keep in mind. And I hate actually to only have kind of a proposal for you today, but I think nobody really has a complete solution. I've seen a bunch of customers starting with it, using parts that I described here, but nobody has a real microservice product out there, right? And this is definitely taking some more time, and I'm not sure if I really want to see something like that. Anyway, compared to what we've seen in the past, ESBs, this is again a very distributed and complex system that will be overwhelming by all its moving parts at that point. I think that networking is one of my least favorite things in those infrastructures. I've had the questionable pleasure to debug a bunch of projects, and at least the ones that I hated the most have had the biggest networking issues. So, and it's just been, might have been a dead switch that led to incredibly bad performance and some monitoring people in ops that didn't really had that on their radar, right? So, and that keeps you searching for ages. This is not going to be better in microservices infrastructures. We have some ideas for registries, centralized or not. Zookeeper is in my mind. Fabric 8 has a bunch of things. As a matter of fact, to me, it all burns down to one thing. If you really want to do that, with all that overhead, with all that networking and technology layers like Docker containers, and deciding the right pieces, this is more than just a technology. It really needs to be aligned with some kind of methodology. And the only thing that might be appropriate as of today is DevOps. So we're no longer just talking about sitting in front of our IDEs. We totally need to learn more about how to use infrastructures and how to define infrastructures and be responsible for all of it. Not only the single deployment that we hand over to some kind of operations guy at the end of the year, right? So this is totally going to change. And still, we have more, which isn't solved as of today. So I'd like to see a lot more monitoring. You've seen some centralized registry approaches in my idea how that infrastructure could look like. Still, I'm missing business capabilities. I'm really missing business metrics for services. I haven't seen a lot around here. I'm pretty sure somebody will come up with it. But that's been one of my favorite enterprise requirements. Governance might be a good idea, but just let's look at patches or security. I mean, I know Docker is working on a lot of things, and even Red Hat is contributing at that point, but still we're not yet there. So it'll take a little more. And put some more cloudy to it, and assume that a bunch of services are running somewhere in a public cloud like Salesforce. We want to use Salesforce information in our application. Or we want to have some stuff which is sitting in an AS400 in the basement. And we might have to enable that in terms of microservices. There'll be a lot of stuff to come. And as a matter of fact, this is only the beginning. So there are a bunch of open source projects, ideas, loggings that you could look into, and they all try to solve a single bit of the piece and puzzle at the very moment. Want to hear a prediction? I don't think that anybody's using it as a sheer architecture approach in enterprises. But again, I still believe that this is a feasible approach for some problems around that we're going to see. So it might be good to have that thing, microservices, in your toolbox as a developer, as an architect, and just have it on the radar. At the end of the day, there might be no single hammer that will solve all our issues anyway, so I'm always in favor for learning something new. Some takeaways for you today. Functional decomposition is pretty much what it takes. I think you can't evolve anything that wouldn't survive as a monolithic application and is still maintainable into something more. So if you're not done that, and if you've nothing enterprisey set up in that area, then you'll never be able to come up with any microservices-based applications. It still is pretty hard to get it right from the start, but I think every modular system that you have somewhere has a good potential to be evolved into microservices. Looking at big corporations, there will be the point where we need to balance costs and needs. It's hard to find a real functional need for microservices. I don't have a catalog which helps you, but I think you'll definitely hear that question at some point, and I think it's very pragmatic, and that's what I like to be back in the days. And don't aim at it first sight. So it's an evolution, and I think that's the only way to success at that point. Are they here to stay? Might be, right? I don't know. I don't have an answer right now. As I said, I still consider it as part of your toolbox. Guys, questions I will. I'd be happy to take them. Otherwise, as I said, please fill the question application. So that should work fine. I'm looking forward to answer all of them. No questions? Oh, at least one. Yeah.
So actually for microservices, can you see them being used in a large, let's say, legacy application that is very much data-driven? You know, because I see that they're mostly, the idea is to use their own databases, but if you're dealing with large amounts of data, you know, gigabytes.
Okay, our microservice is a solution for data-driven large databases. I don't think so at the very moment. When it comes to large data sets, it's all about performance. And I don't see that with the gospels that many microservices are preaching at the very moment. I mean, that's one thing where I'm pretty conservative when it comes to using it. And I highly advise you to look into more service protocols that are a lot more performant at that point. And I think message-driven approaches might fit the best for it. It still might need to be asynchronous, and you run into a lot of other issues by doing it. But still, yeah, I don't think it might be a good solution or the best solution. Yeah.
So is there any monitoring solution for monitoring this kind of microservice architecture where modules communicate asynchronously over events?
Is there a monitoring solution for asynchronous event-driven architectures at that point? Non-open source thing that I know of as of today. I think looking back at some complex event processing systems from different vendors, they had something built in, but I'm not aware of any solutions which are here and ready to use as of today. I'm not 100% sure, but as far as I know, HornetQ is actually moving into ActiveMQ. So those two projects are definitely merging. I'll look that up. I'll come back with some more answers on that, but that's what I have in mind about it. I'm not evangelizing a particular MQ solution here. I like ActiveMQ because it's pretty lightweight. And I hate all the other big messaging solutions anyway, so that's pretty easy. I like open source. Okay, that's been it. I'm around for the rest of the conference. Thanks for your time. Bye-bye.